Hello good people, I'm going to continue talking about van der Waals forces. In particular, I want to look at the London dispersion force. This is another subset of the electrostatic attractions. It occurs between nonpolar molecules and it is due to the creation of temporary dipoles. What are those? Well, let me look at the example of two nitrogen molecules. These molecules are nonpolar. Therefore, there are no partially positive and no partially negative charges. How can these two molecules attract each other? We need to think in terms of electron clouds. In case of these two molecules, the electron clouds are evenly distributed. Keep in mind that I'm not a good artist, and this is a very static picture. In reality, things are far more dynamic. These electrons are constantly moving around. And so, when it comes to the molecule on the left, the electrons, for the tiniest moment in time, might all scooch to one side of the molecule. And when that happens, we will end up with something like this. The electron cloud on one side of the molecule is far bigger or far thicker than on the other side. This means that for a brief moment, I have a temporary dipole. The side with more electrons will become partially negative, while the side with the fewer electrons will become partially positive. And now, this temporary dipole might induce a dipole on the molecule next to it. All of these electrons on the left molecule will repel the electrons on the right molecule. And so the electrons on the right molecule will scooch over as well. And we will end up with something like this. The electrons on the right molecule have now been disturbed as well. And as a result, we will end up with a temporary dipole. And now that we have two temporary dipoles, we can talk about an electrostatic interaction. The partially negative side of one molecule will be attracted to the partially positive side of the other molecule. Please note that of the van der Waals forces covered, this one, the London dispersion force between two nonpolar molecules, is the weakest. Remember, this situation is dynamic. We have a temporary dipole. And from one instant to another, both of these molecules might revert to the starting position where the electrons are evenly distributed. The moment that happens, any attractive force that was present due to the London dispersion force will dissipate. That is all for now, and I will see you on the flip side.